before you start, no, don't go yet. I just have to apologize to everybody for what you're about to be subjected to. So I hit like, 20 slides at 15 seconds before, and I was like, oh, that was easy. So now I'm going for 30, 10 seconds each, okay? So this is going to be an onslaught of verbal nonsense, but go. I'm Tim, I work at Planet, and I want to thank Planet for sending me here and also supporting the work that we're all doing here this week. I'm here to talk about analytics at Planet, and I want to clarify first what type of analytics. So I'm interested in the third type of analytics, where we do analysis on imagery to provide more value to users. So why analytics? Like, why would Planet be talking about analytics? Nominally, we're a pixel company. We're a satellite image data provider. So if we look back at Landsat, we have 45 years of Landsat program that's amassed more than 3 million scenes in its archive. This is amazing, an amazing resource. During that time, a generation of image analysts, tools, specs, and techniques evolved around dealing with that quantity of data. At Planet, we provide more than that quantity of data every 5 days. So we have to rethink all of that tooling, all of those specs, all of those techniques. Just don't work with that volume of data. Fortunately, during that same time period, computer vision techniques have advanced radically. We have machine learning models that can do things like extract images, extract objects from images, and provide higher value per byte that we're delivering to customers. So at Planet, we've launched this foundation level feeds. I'll talk today about 3 different types of feeds. Vessels are an example of object detection-based feeds, running object detection models on our daily imagery. And roads and buildings feeds are examples of segmentation models run on our base maps. And basically, the purpose of all of this is to provide you the same cadence, the same frequency of images, of information as we provide in the imagery, but higher value information, and then delivered with a convenient API. So you basically get more value per byte, or more value per data that we're delivering. A few more terms here. When we say feed, we're talking about spatial temporal information that's derived from imagery. Users have subscriptions for feeds. So a feed might be a ship feed, and a user might have a subscription in this port out here for a few months. We get an observation that's an image or a mosaic quad from our base map series, and then we generate a result from that. So as an example, here are some pictures showing object detection feeds, vessels, boxes around images, and with data like this, Global Fishing Watch, for example, has been able to pair this with AIS signals to locate and then respond to illegal fishing activities. So this is much more efficient than having to consume all the imagery. Another example, roads and buildings data. We all know about the turmoil in Syria and the horrible events, millions of people displaced. These are internal displaced persons camps. If we look at through the end of 2017, you first see the development of roads. These are in our monthly base maps running road segmentation on them, followed by the building development into 2018. You often see this pattern where road development is a precursor to other activity, deforestation, etc. Oh no, I need to give you access to view this video. I don't think that's going to work.
That's good because
I'm out of time. Okay, so that was segmentation on the whole globe. So it was a cool video, the globe spinning around, took way too long. But great, all that data run over the whole globe. How do we get access to it? You'll be familiar with the Features API here. Here in our world, subscriptions are how users get access to the data. Those are represented as collections in the Features API. So I might have ships in a particular area over a certain time period. You also don't have access to this video. That lets us build web UIs like I was about to show you here, where you can get attribute information from the features over our imagery. And we don't stop there. It's not just for your web browser. We've also supported the development of the features driver in GDAL, and even just got in this merge request into QGIS. So now there's a features provider in QGIS. So you can load up your Planet Analytics data here. I'm connecting to analytics, searching for ships, searching for buildings, searching for swimming pools. I'm going to LA, not really, but let's say I was going to play golf here and I want to know where the nearest swimming pool is. So you can use that data, this data for that purpose. There's a lot more, but I think I'm out of time. In the future, we're heading towards extensions, things we'd like to propose as extensions to the features API. STACs, or how you can do aggregation, so you don't need to work with geospatial data. You don't even need to know how to deal with GeoJSON. You just want to get scalar values or counts in a time series, let's say. We also have, and I think others do, vector tile rendering services that accompany our features API. And then what I was going to show you, which you also don't have permission to, I think, is video of change detection. It's the next feed that we're going to be developing based on our roads and buildings feed. So instead of downloading all the roads and all the buildings data, if you just want to know about the changes, those are represented as vector features in that API.